Welcome to Web Handling. My name is Dave Roisum. In this clip, we continue a series of successful case histories where the source of bagginess was pinpointed and fixed. Those of you who've been in my Web 101 class will recognize that this is the one example that I will teach if I have the time, because it illustrates so many important problem-solving tools and techniques. Those of you who have not been in my Web 101 class, well, what are you waiting for? In any case, this case history is so long that here it will be broken up into two clips. The first part is the straightforward approach where we get stuck. The second part is the getting unstuck part and the path to remedy. Let's get started. I love this teaching example for many reasons. First, it is a simple roll-to-roll process that has only one process element, a simple hot calendar. Many other processes are far more complicated and thus make troubleshooting and teaching more challenging. The second reason I like it is because it illustrates generic thinking that is necessary to avoid distracting details. By that, I mean that students will soon be wondering what the web is and what the process is doing. These questions are entirely unnecessary and unhelpful, especially to begin with. However, I will provide the details only to satisfy your curiosity so we can move on to much more important things. The supply roll is a fluffy nonwoven. Think like cotton batting. The hot calendar compacts and partially bonds the fluffy nonwoven to make a cloth-like product such as used in hospital and industrial garments, table covering, personal care products, and many, many other items. Okay, let's move on because none of this is very germane to good baggy web problem solving. In any case, the patient presents with the following complaints. Vivid baggy edges coming out of the calendar. Upstream of the calendar, no profile is readily observable in the incoming fluffy web. The problem is chronic, meaning that while it comes and goes a bit with time, it is ever present to a degree. Note the use of some medical terminology like presents. That means that the patient shows up or tells, and chronic, which means the complaint is frequent or common with that patient. Let us try to first clear the solution space up a bit by asking whether we can eliminate the winder from consideration. Since bagginess is readily visible coming out of the calendar, this would seem to be a safe assumption. However, to be totally sure, we could e-stop the machine and recover the material in the calendar to wind-up section for closer inspection. Next, we can ask if we might eliminate the raw material. Since every grade tends to misbehave, one might conclude that it must be the calendar, since surely every raw material supplier can't have the same problem. However, this is an unsafe and unsupported conclusion. There are many edge effects that are unavoidable. Salvage edges in textiles is one example. Unsupported drying in paper machines is another example. In these cases and others, every raw material has the potential to misbehave and usually does. Next, we could ask if DOEs or statistical tools would be a good choice for analysis. Here we might guess, probably not. There are at least two reasons. First, chronic and especially ever-present tendencies tend to make variation response small, and thus statistics will tend to be quite noisy. Second, as we learned in our Web 101 class, bagginess is extremely time-consuming and difficult to measure in even the best of cases. Noisy trials and noisy machine measurements together tend to make for garbage in, garbage out analysis. As we learned in my critical thinking class, we should begin our troubleshooting tree by starting at the base. That is, all problems are found in the arenas of man, machine, and/or material, what I call the 3 M's. Here, we will eliminate the operator from further consideration because he does not directly touch the material and can only act through the machine. Next, we will build the shape tool into most steps of Baggy web troubleshooting process as I described in the last clip. As we learned there, the shape of the problem must resemble the shape of the cause. The shape of the problem is smile-shaped length or frown-shaped tension distribution. We might begin our search for a smile or frown shape by going to the test lab and checking profile. Profile of basis weight, thickness, strength, and, in fact, anything that the lab can test. Nowhere did we see a frown or smile shape. Does this mean that the raw material is okay? Absolutely not. Just because you can't see or measure it does not mean that it is not there. You could have the wrong measurements. Who is to say that the measurements that the test lab happens to have are the right ones for this problem? Or you could be measuring wrong. In other words, the right measurement type, but the instrument or technique does not have the resolution to pick up the problem. This, as we saw many times in Web 101 and elsewhere, is a very common situation when trying to measure thickness. The winder could make bagginess and other problems at variations of 1 to 10% of total thickness. Yet, most instruments are unable to measure with that kind of resolution on thin materials. Next, we move on to the calendar. We use our very best techniques to profile temperature, diameter, nip impressions, and so on. Our best techniques fail to find a smile or frown shape. Does this mean the calendar is okay? Again, absolutely not. Just because you can't see or measure it does not mean it is not there. You could have the wrong measurements. Who is to say that the measurements the maintenance and engineering departments have are the right ones for this problem? Or you could be measuring wrong. In other words, the right measurement type, but the instrument is not good enough for the purpose. It is plausible, or at least possible, that the calendaring process complains at variations below what our chunky thermometers can detect, something like 2 degrees C in the best of industrial situations. Perhaps our nip impression paper or even sensors are too crude. Perhaps the system complains at variations of 10 kilonewtons per meter, but we can only sense tens of kilonewtons per meter. We began in the most reasonable fashion with all diligence, yet our best efforts could not find a smile or frown shape in either the material or the machine. The result of all of this effort is data, but no information. Data is not merely worthless here. It is worse than worthless. It has negative worth. We have spent time and money and we got nothing to show for it other than graphs that will totally bore and frustrate and confuse anyone you show them to. In short, we are stuck. Our very best efforts have not resulted in even the tiniest step towards understanding the problem, even though this is exactly what we should have done. Now what? Well, We will continue this in the next clip. In the meantime, I want you to start thinking in different ways. Instead of measuring things, how about simply paying attention? Instead of making reasonable assumptions, how about seeing the world as it is rather than how we want it to be? Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for the next clip where we will show how to crack this problem by simply paying attention and not making assumptions.